Okay, so a complex fraction, this is an example of a complex fraction, okay? It's a fraction with a fraction in the numerator or the denominator, okay? So you're going to have, in this case, here's my, my big fraction, okay? This is the numerator, this is the denominator, and we have addition in the denominator. Okay, so normally if you just have a fraction in just a fraction, you can just multiply by the reciprocal. That's what we did before, okay? But what makes it a complex fraction is because we have that addition sign here, and so we have to do something a little bit different, okay? So there are two methods that you can do, okay? We're only going to go through one of them. The first one is that you can write the numerator and the denominator as a single fraction and then divide. So multiply by the reciprocal, okay? So this one is already a single fraction. The denominator right here, you would have to do what we did yesterday, where you would combine them, you find the common denominator, and then add them together to get a single fraction, okay? That option is in your book, and you can read through that. If you want me to show you that at another time, I can show you that. And I want to show you the other method that's a little bit, I like the other way, this option 2 better, because you don't have to figure out how to combine the fraction. Okay, you get to cancel things. So that's what I'm going to show you. So this is the same fraction. So if you were writing it down, it's the same one. Okay, this one is option 2, which is to multiply the numerator and the denominator by the least common denominator of every fraction. Okay. So we're going to find what the least common denominator is of each fraction in the numerator and the denominator, okay? So of all of those together, and then we're going to multiply on top and bottom by that, okay? So you'll see what I mean by that in a second. Okay, so let's write that down. Okay, so this is one denominator. I have x plus 4. In this denominator, I have x plus 4. And in this denominator, I have x. So what is my least common denominator between all of them? What am I going to have in there? An x and x plus 4. That's my least common denominator. Okay? I have 1x plus 4 and 1x. Okay? Now, what we're going to do is we're going to multiply the numerator and the denominator by that. So we're multiplying by 1. We're not changing any values, okay? So I'm going to multiply by x times x plus 4 over x times x plus 4. Okay? Now, if I look at just the numerator, okay, is this x times x plus 4 multiplying to the top and the bottom of this fraction? Or just the top or just the bottom? So if I wrote just this part, so 5 over x plus 4 times x plus 4. Just the top, right? Because this is technically over 1. Okay? So when I multiply that to the top, okay, you're going to get 5x times x plus 4 over x plus 4. What's going to happen? It's going to cancel. So you're going to have just a 5x on top. Does that make sense? Okay, so when we do that, this is technically, we'll put a little over 1 there. This cancels with that, and I have 5x on the numerator. Okay? Now the denominator, I'll write that one up here. So we have 1 over x plus 4. And we're going to be multiplying by x. So this has to distribute to both of them. Okay? So we're multiplying by x times x plus 4. So what is going to happen there? For just that part, right? And then we have plus 2 over x. We have x times x plus 4. So what happens in this fraction? What goes away? X plus 4. And so I'm left with just an x. So this x plus 4 is going to cancel over here. Those two x plus 4s cancel, and I get just an x plus what cancels over here? 2 over x times x plus 4. Just the x cancels. So I'm left with 2 times x plus 4. Okay, so both options, the option 1 and this one, they both require you to find the least common denominator, but this one gets rid of the denominator so you don't have to deal with them anymore. Does that make sense? So now it's just a matter of simplifying the denominator there. So we multiplied by the least common denominator in the top and the bottom so that we can cancel the denominators. Okay? So this becomes x plus 2x plus 8. So my fraction is 5x over 3x plus 8. Okay. Questions about that? Let's go back through it just to make sure you understand. So we found the least common denominator. Then we multiplied by that in the numerator and the denominator. Okay? So we looked at what would cancel. So something is going to cancel with this least common denominator because the least common denominator contains all of the denominators. Okay? So that cancels and I'm left with just a 5 and an x on the top. On the bottom, you have to make sure you distribute it to both of those, and the x plus 4 cancels there, and I'm left with just an x, and the x cancels there, and I'm left with just an x plus 4. And then we just combine. Questions about that? Okay, so that's the end of 5.5. Now we're going to go to 5.6. So you'll be able to do those last 3 examples, and we'll have time for questions. Tomorrow's just a review day. So we'll have question time at the beginning and time to work as well. Okay. So today we're going to be solving rational equations. It's the last section in this unit. And then the test is going to be next week. Okay. So next week, Thursday and Friday. So starting review on Friday, and then Tuesday and Wednesday we'll be reviewing the class as well. And then Thursday, Friday, your test. Okay. So it's solving rational equations, and then you're going to determine which numbers cannot be solutions and explain why they cannot be solutions. So here's our first one. 3 over x plus 1 equals 9 over 4x plus 5. Have you solved something that looks like this before? Yeah? What do you do to solve something that looks like this? Remember? This can be classified as a proportion because it's a fraction equals a fraction. So you have 2 ratios equal to each other. Remember what you did when you had that? I don't want to remember what you could do. What do I need to get rid of? Can I solve it like it is right now? What do I want? We want x by itself, but is x going to be by itself in the denominator? So we want to get rid of denominators, right? How can we do that? Multiply the denominator to the other side. Okay? So you can multiply the denominator to the other side. That's what you're going to be doing, or you can think of it as cross-multiplying. That's what you're doing. You're multiplying it to the other side. Okay? So anytime you have just one fraction equals one fraction, we cross-multiply. So this one is going to go over here, and this one is going to go over here. Remember doing that now? Maybe? So this, we have, I'm going to put parentheses around that. So we're going to have 3 times 4x plus 5 equals 9 times x plus 1. So whenever we have a fraction equals a fraction, it's pretty nice to just be able to multiply to the other side. Okay? When we have addition or subtraction, we have to do something different. So go ahead and distribute and finish solving that. There we go. So we should have gotten x equals -2. 12x plus 15 equals 9x plus 9. Subtract the 9x, you get 3x plus 15 equals 9. Subtract 15, divide by 3, and get x equals -2. Okay, questions? All right. Let's go to the next one. Okay, so this one is not a fraction equals a fraction. Okay? So again, there are two options for you to solve this equation. One of them is to combine the side that has the addition. So on the left side, you can combine it like what we did yesterday. Adding, you'd have to find the least common denominator, multiply, and then end up cross multiplying like the last one. Okay. The other method is to multiply both sides by the least common denominator. Kind of like what we did for the complex fraction, where we eliminate the denominators. Okay, I tend to like that way because then I don't have to deal with fractions anymore. Okay, so what I'm going to do is find the least common denominator of all of my denominators. Okay, so my least common denominator, I have an x, and I have a 4, and I have an x. So what's going to be in my least common denominator?
4x.
What'd you say?
4x.
4 and x, right? So we have a 4 and we have an x. So that's my least common denominator, and I'm going to multiply that on both sides of the equation. Okay, so don't think of it as multiplying top and bottom, because that was the complex fraction. Now we're doing an equation, so it's on both sides. Does that make sense? So you have to do something to both sides of the equation. So I'm going to multiply by 4x over here, and multiply by 4x over here. Now this is addition, so that 4x is going to distribute to both of those. Okay? So when I multiply across here, I'm going to have 4x times 5. So I have a 20x over x, and I'm just going to keep it like that for now, and then we'll simplify in a second. And then over here, we have plus, I'll just keep it as a 4x times 7, so you can see the 4's will cancel. Okay, so over here we're going to see that that x cancels with that x, so the denominator goes away and I have just 20, and this 4 cancels with this 4, so I just have a 7x on that side. You see how that works? Multiplied by the 4x and we canceled our denominators. On this side, when we multiply by the 4x, we'll get 36x over x, so the x's will cancel, and I'll have just 36. Okay, so I like that way because now I don't have to deal with denominators anymore. I don't have to try to combine them, cross multiply, that type of thing. Okay, so if I multiply by the least common denominator on both sides, they go away. Okay, and then just solve this, simplify. So minus 20. So 7x equals 16. Oh, I didn't see the negative there. I messed that up. There should be a negative there. A negative 9 over x, so negative 36x over x. So instead of that, you should have a negative 56. And then divide by 7. And so x is equal to negative 8. Questions? Okay. I want you to try this one from the start. We'll go through it together, but I want you to find the least common denominator and multiply on both sides of the equation so that I can tell if you're understanding that part. Okay? So find what the least common denominator is and then multiply that on both sides of the equation. And you can talk with your table partner. when you multiply by this, you're gonna have like that part, x times x plus 5, and then minus, and then you're not, it'll just be canceling the denominator. Make sure you also multiply it times the 1. Okay. Don't forget about that 1. Multiply the denominator times that as well. Okay, before you get too far, I want to make sure we're on the right track. So least common denominator, what did you guys get for your least common denominator? What's common? Huh? Okay, so x minus 5. Is that what you said? Okay, x minus 5 is all one thing. Okay, so x minus 5 is a factor, and it will be in your denominator. Okay, so x minus 5, and what else? X. Okay, so in order to be able to get rid of those denominators, both of those have to be there. Okay, so now I'm going to multiply both sides by x times x minus 5. Okay, and you remember you're multiplying both of those by that. So when I multiply the 1, it doesn't have a denominator, it's just going to be x times x minus 5. Minus, and then I'm going to do 8 times x minus 5. Over x minus 5 for the time. Okay, so anything cancel there? The x minus 5. Okay. And then I have a 3x times x minus 5 over x. Anything cancel there? Gx. Okay? So that cancels. So now we write down what we have left over. So we have the x times x minus 5. We might as well multiply it out while we're bringing it down. So we're going to have an x squared minus 5x. Can you see that? And then these canceled, so I have just a minus 8x. And then over there, the x is canceled, so I have 3 times x minus 5. So 3 times x minus 5, we have a 3x minus 15. So I now have a quadratic on that one side. And so in order to solve this, what will I have to do? What'd you say? Set it equal to 0. So again, I like to have my x squared positive because it makes it easier to factor. So I'm going to move everything to the other side. Okay? So I have x squared, and I'm going to subtract the 3x on both sides. So I have a negative 5x minus 8x minus 3x. What does that give me? Minus 16. And then I'm going to add the 15 over. Okay, I'll give you a minute here to try to factor that. Has this factor? What's going to multiply to give me 15 and add to give me negative 16? Good. So negative 15 and negative 1 multiply to give me positive 15. So then my x's are 15 and 1. Okay, so again, anytime I get a quadratic, and then I have two solutions, I have to go back up and check to make sure that it's not going to give me an extraneous solution. Okay, so in this case, what do I have to be concerned about in my original equation? What do I have? What values could I not get for x?
0 and 5.
0 and 5. Why is that?
That would make it 0 in the denominator.
Right, so with a rational equation, we don't want to have any zeros in the denominator. So do 15 and 1 make the denominator 0? No. So as long as I did everything right, then this is going to check out, and both of them are solutions. Okay? So I check them. Both are solutions. And I don't have any extraneous solutions. I just have 2 in that case. Okay? Questions on that one? How are we feeling about solving equations right now? Give me a thumbs up, sideways, thumbs down. Okay, let's do another one. Remember that you'll want to factor any denominators that you can. So far we haven't had to do that. But this one, we have an x squared minus 9. How does that factor?
X plus 3, X minus 2.
Thank you. Okay, so find what your least common denominator is going to be. Rylan, what'd you get for your least common denominator?
X minus 3 squared X times X plus 3.
Okay, so the x minus 3 squared part, you don't actually need 2 of them, okay? Because I have 1 here and 1 here, so I only need 1. Does that make sense? Because if I multiply on both sides, that will cancel. I don't need 2 to be able to cancel, okay? So just x minus 3, x plus 3. That's my denominator, my least common denominator. So now I'm going to multiply that on both sides of the equation and cancel any denominators that I have, okay? So multiply times x minus 3, x plus 3, times both of those, and x minus 3, x plus 3. Okay? So over here, what's going to cancel?
X minus 3.
So I'm going to be left with 6 times x plus 3. Okay, and then this denominator is the same thing as that. X minus 3, x plus 3. So both of those are going to go away. Okay, you can write this out and cancel again if you want to. I'm just going to try to save a little space here. So I have 8x squared because both of those cancel. Does everyone see that? Okay, and then the next one, I have an x plus 3, and that's going to cancel with the x plus 3. So I'm going to be left with this x minus 3. Everyone follow where we went there? Okay. Now multiply everything out. We have a quadratic, so you'll want to get it to one side. Factor and solve. Okay, so multiply. We have a 6x plus 18. And we have a negative 4x squared plus 12x. Did I do that right? So combine your like terms, get it all to one side. I would try to get it to the right side because that's going to give you a positive 4x squared. So subtract the 6x from the 12x and subtract the 18. Right. So those are all even. So what can I do? Take out a 2. Okay, so I'm going to divide by 2 on both sides. So I have 0 equals 2x squared plus 3x minus 9. Now factor. Give you a minute to factor that. All right. So 3 and 3 are going to work. Which one's going to be positive? Which one's going to be negative? 2x and x. So let's check that. So 2 times 3, that gives me a positive 6. Minus 3 gives me a positive 3. Okay, so that's just guess and check. Try it out, multiply it out, see which ones work. Okay. Then set them equal to 0. So 2x minus 3 equal to 0. That's going to give you 2x equals 3. So x equals 3 halves. And over here we get x equals negative 3. Okay, so now, whenever you're getting two answers, make sure you check for extraneous solutions. So go back up, 3 halves and negative 3 is what we have. So if I look at the original one, is 3 halves going to make any denominator 0? 3 halves, 1.5, any of those? What about negative 3?
Yeah.
Yes, it'll make this one 0 and that one 0. So that's an extraneous solution, and then cancel that one out, and 3 halves is my only solution. Okay, and that's all for today.